Alright, our goal in this video is to talk about some special angle pairs, right? Some angles that have special relationships that we want to kind of assign a vocabulary word to, and when we hear that vocabulary word, we know automatically how these angles are related to each other, so we can maybe do some solving or setting up a diagram or something just based on that keyword. Okay, so we're going to learn, I think, about 4 of them today, maybe 5. Okay, so our first one, let's just jump right in, is called adjacent angles. Okay, so this keyword adjacent is something that you should have heard before. The word adjacent just means next to, and so in the official definition it says 2 coplanar angles with common sides and common vertex and no common interior points. And that's kind of a little fancy. What we really mean when we say adjacent angles is 2 angles that are right next to each other and they share one ray. Okay, so if you notice, here are my adjacent angles in my diagram here. Okay, I have this angle MA, totally missed there, MA, okay, and then AT. So I have this angle MAT, okay, and then I have another angle TAH, okay, and I'm going to say that they are adjacent angles because they're right next to each other, and AT is a shared ray, right? They share one of the walls of their angle, and so they are adjacent to each other, okay? This is important because adjacent angles are what we need to do the angle addition postulate, which is what you saw in the last video. So if I say that 2 angles are adjacent, in your head you might say, well, wait a second, if I know how big, in this case, MAH is, I might be able to use the angle addition postulate. So adjacent angles are good for that. Okay, we'll see some of those show up. Okay, here's another really important one. Okay, vertical angles. Vertical angles are 2 angles, again, here's your official definition, whose sides are opposite rays. Okay, 2 angles whose sides are opposite rays. So let's kind of like use that definition, and then we'll kind of see what it means a little bit easier in diagrams. So if I were to take, for example, this angle right here, BEC, okay, and I wanted to know, are there any angles in this diagram that are vertical angles with that? Here's what this whole sides are opposite rays means. Remember, opposite rays were angles or rays that traveled basically in a straight line away from each other, but they were connected at a point. So if I were to start here at E, and I wanted to know if there's an opposite ray with EB, I'm just going to travel away from it in a straight line. Okay, and if you notice, I went down from E to D, and then I could do the same thing with EC and say, where's its straight, its opposite ray? So making a straight line with EC, I would start at E, but I would travel towards A. Okay, and so I would say AED is a vertical angle with BEC because its 2 rays make straight lines with BEC's rays. Okay, and so another way we can think about this, if we want to think about the angles and not the rays, is we can say here's the space that BEC occupies. That's the angle itself. If I jump over a vertex, if I have 2 straight lines intersecting, okay, and I jump over a vertex, I'm gonna get to the vertical angle. Okay, so these ones that jump over E are vertical angles. Okay, so they're not right next to it, but they're over the vertex itself. But again, the key is that they have to be straight lines intersecting each other. BD and AC are straight lines that intersect each other. So there's actually another set of vertical angles on here. I can actually say, if I were to think about this one, okay, AEB, if I jump over the vertex to the other side, because these are straight lines, I would say that these 2 are also vertical angles. Okay, so we can name several sets of vertical angles in this diagram. Okay, so here's your third special angle pair, one that you've probably seen before, okay, and they are complementary angles. So complementary angles are 2 angles that when I add them up have a sum of 90 degrees. Okay, so in my diagram here, those angles are adjacent to each other. They don't necessarily need to be adjacent to each other. I don't think I have an example that they are not. Okay, so these might be disconnected and in different parts of the diagram, but they can still be supplementary if they're not. I'm sorry, still be complementary if they are not connected to each other. So I just want to kind of point out how I remember complementary. So COMP is how I start complementary. If I take this like nice little line here and I just place it kind of right at the beginning of it, if you notice, I get this 90 at the beginning just with one quick line. And so that's how I remember that complementary means 90 degrees. Okay, so here's a very quick problem dealing with complementary. So this box down here also represents right angles. Okay, so we saw that in the last video when we talked about angles. We said if something equals exactly 90 degrees on the diagram, we'll use this little box here in the corner. So we're basically saying that this big space here is 90, and because x and x plus 30 are in the space, the angle addition postulate says that if I add together x plus 30, that I should get 90 degrees. Okay, so I can now solve this and say that 2x plus 30 is equal to 90. Okay, which means that 2x is equal to 60, and so x has to be 30. So in this case, if we want to go a step further, this is a 30-degree angle, and this is 30 plus 30, which is a 60-degree angle. Okay, so but the idea here is that this angle that we labeled x, and this angle that we labeled x plus 30, they are complementary angles because they add up to 90 degrees. Okay, so we also have one that adds up to 180. These are supplementary angles, right? And I am giving you in this case 2 examples of supplementary angles. One of those cases are connected, okay, and the other one are disconnected. So 139 and 41, even though they are not adjacent angles, they are still considered supplementary. It doesn't matter whether they are adjacent or are not adjacent. So keep that in mind. They might be in completely separate parts of the diagram, but if they add up to 180, they are still supplementary angles. Okay, so here's your last one. Okay, and this one says the linear pair postulate. So we're going to see this word linear pair show up fairly frequently. Okay, so let me grab my highlighter so we can keyword this one. Okay, 2 angles form a linear pair, then they are supplementary. And so really, what's a linear pair? Right? So we want to be able to identify them. Okay, so if I were to take, okay, I'm going to come down to this diagram here. Okay, actually, we're going to start off. I'm going to get rid of this diagram. We're going to start from scratch because this is important. So if I were to start off with a straight line, so let me grab my line tool so we can draw ourselves a straight line. So if I were to take a straight line like this, okay, and then I were to somewhere on the line put down a point, okay, and draw a ray out of it. So let's say I drew a ray that looks something like this. Okay. Okay. What I did was I just took the space that was above that line and I created 2 angles out of it. So we said that a straight line, okay, or a straight angle was 180 degrees across. So if I were to kind of just look at this, I would say that this from one ray to the other is 180 degrees. Okay, and I just split that into 2 new segments. So these 2 little angles that I just created, which are the one on the left here, this little space here, okay, and then the one right here, that if I add those up, I should get 180. Okay, and so generically, here's what this means. If I were to go way back to this line, okay, there's 180 degrees here. Okay, any angles that are above or below a line are going to also add up to 180. They're going to, so we would call those 2 angles that add up to 180 a linear pair, because when I put them together, I'm making a line. Okay, so it's related to supplementary in a lot of ways, and you can actually see in my last picture here that the 45 and the 135 actually made a straight line too. Okay, so supplementary and linear pairs are related, but when you see a straight line and you see any kind of angles that are above a straight line, they are going to add up to 180 degrees because of linear pairs. So here's an example of that. So I'm giving you very little information here. I'm saying, okay, I have an expression for this angle on the left and an expression for this angle on the right, and they want to know what is the actual measure in degrees of the one on the left, K, P, L. So here's what we're going to do. We're going to look at this and say, okay, well, I don't know that they're equal to each other. They didn't tell me how many degrees both of them should add up to be, but because they are above a straight line, here's my straight line, okay, I'm going to say, because they are above this, okay, that they should add up to 180 degrees because KJ is a straight line. So I'm going to say that the measure of angle KPL plus the measure of angle LPJ, okay, should equal 180 degrees. And if someone were to ask why, I would say, well, the linear pair postulate says if 2 angles make a straight line, then they are supplementary, which means they should add up to 180. Okay, so I'm going to say that 2x plus 24 plus 4x plus 36 should equal 180. and then I can just do the algebra. So 6x, when I add these two together, it looks like I get 60 equals 180. And that means that 6x is equal to 130. And when I divide both sides by by 6 to find out what x is, I find out that they are 20 with 20. 6 goes into 13 2 times with 1 left over. It looks like we're going to get a decimal out of this, which is fine. Okay, so I'm going to say 130 divided by 6. Okay, 21. It's about 21.7, right? So nothing nice. So, oh, that's why. Because I can't subtract. I was wondering why my problem didn't work out nicely. This is supposed to be 120. Okay, 120. And that, when I divide 6 by that, I do get something nice. I just get 20, okay? So excuse my poor calculating skills. Okay, so x is 20, and now when they say what is the measure of KPL, I can plug a 20 in here and find out that this is really 40 plus 24, which looks like 64 degrees, okay? So I can answer their question once I find the value of x, okay? So just be careful with that. All right, so let's see if I have anything else to worry about, okay? So I'm not going to go through this example of just naming them. I think that definition-wise, you have a pretty good idea. Okay, so let's go through and wrap this up and talk about angle bisectors, just angle bisectors I think we have to talk about. Okay, so here's our last definition. Okay, an angle bisector is a ray that contains the vertex of an angle and divides that angle into two congruent parts. So I'm just going to kind of get right into this and say this is really the midpoint. It's not really midpoint because midpoints are for line segments, but it's the midpoint version for angles. Okay, so remember when we were talking about lines, and I said if I have some line that's like maybe 24 units long, and I put a midpoint in here, that this is going to be broken up into 12 and 12. Right? When we see the word midpoint on a line segment, we know that the parts that were created are now equal in length, and they are exactly half of the original line segment. So this is the same thing, but in angle terms. So if I had this angle down here, and I said that this angle, the total POD, and I told you over here the measure of angle POD is, let's say, 120 degrees. Wait, that's not accurate at all. That can't be 120 degrees. So let's try that again. The measure of angle POD, let's say, is 40 degrees. That might look a little bit more accurate. So I know that this big angle is 40 degrees, and I tell you that ON, this ray ON going down the middle of POD, is an angle bisector, and I'm going to use the angle symbol, which you might see, an angle bisector, okay? Then I know that that 40 degrees got split into equal parts, and the two new angles that got created have to be 20 and 20, okay? And so the idea of angle bisector is used to split segments. So again, that word bisector means we create two equal sections. Okay, so you'll see algebra problems. Okay, when I give you, I'm not going to go through this, but you get the idea that if I say the word angle bisector, that the two little pieces here are equal to each other, and if you notice these little arcs down here, those are indicating also that those two are equal. So I can just set those expressions equal to each other, and I can solve. Okay, same idea here, just with some more algebra. If I see the word bisect of CAB, I know that this segment here and this segment here, these two angles that were created, are equal to each other, and then we can do the algebra. Okay, so we will do more of this stuff in class, and you'll get a lot of chance to practice doing the algebra, but those are the basic ideas.